thing I wanted to teach was how to graph rational functions. And if you don't know, a rational equation looks like something like this. A rational is when you divide one function by another function. So you have a function over a function. First, when graphing a rational function, you need to find all the necessary information. And in order to find all this necessary information, the first thing you want to do is factor out both functions and put it in factored form. Alright, and we already went over factoring, so I'm just going to do that step by pulling out the greatest common factor, which would make this 5 times x squared plus 8x plus 16. And then we can factor that into two different solutions by just going 5x plus 4, x plus 4. And now the bottom one would end up being x plus 4 and x plus 3. Now one of these x plus 4's cancels out. And when two cancel out, we call that a whole. So remember that x plus 4 was a whole. Okay, so we end up getting 5 times x plus 4 over x plus 3. And that's it completely factored. Now these two functions are exactly the same. One's in standard form, one's in factored form. Now we already said that the whole was at x. It was at x plus 4, which makes it x. Well, the whole would be at negative 4. Because it's whatever makes that equal to 0. So the whole is negative 4. Okay. Now let's do x-intercepts. Well, x-intercepts is when you make the top part equal 0. So if you put a negative 4 in here, it'll be 5 times the quantity of negative 4 plus 4, which is 0. So 5 times 0 equals 0. So the way to make that equal 0 would be when x is equal to negative 4. So the x-intercept would be at negative 4. Now we have 3 more things to fill in. Horizontal asymptote, vertical asymptote, and the y-intercept. Now the vertical asymptote is when you make the bottom number equal to 0. So what plus 3 equals 0? That one's an easy one, it's just negative 3. So we have vertical asymptote at negative 3. Now we need to figure out what the horizontal asymptote is. Now for this one we'd use these two numbers. If these are the same, which they are, you divide the leading coefficient by the other leading coefficient, which is an imaginary 1 there, so 5 over 1. So the horizontal asymptote would end up being 5. Now to find the y-intercept, you need to put 0 in for x on the top and on the bottom, and then solve it and put it as a fraction over each other. So what you're going to do is you go 5 times 0 plus 4, so it's, pretend this is a 0. 5 times 0 plus 4, well 0 plus 4 is 4, so 5 times 4 is 20. Over 0 plus 3, which is 3, so 20 over 3. Which is about 6 2/3. So let's just put that as 6 2/3. Just to make it easier than 20/3. Now we have all the necessary information to graph it. Alright? Now let's go to the graphing. Okay, well, we found all the information. That wasn't that hard, but now how do we put that all in the graph? Well, we're going to start with the hole, okay? If we know that the hole is at -4, then we know when the line crosses x equals -4, we just put a hole there. The line cannot cross through there. So it'll just be a blank spot in the line. So actually we can't do that yet. Well, if we can't start with that yet, let's start with that x-intercept. The x-intercept is at -4. And let's see, 1, 2, 3, 4. -4. The horizontal asymptote is at 5. The y-intercept is at 6 2/3. The vertical asymptote is at -3. Now the horizontal and the vertical asymptote are lines that will almost never be crossed. They separated into different quadrants now, instead of the axis is doing that. So this is what it looks like now. They have all this information plugged into it. But now we need to draw the lines. See, the x-intercept is on this side. It'll get really close to the asymptotes, but will not actually touch. Same with this side. Goes through the y-intercept right there. We can't forget to put in the hole. And this is what the graph would look like. And that's how you find all the necessary information to create this.